Let's see here. So write this down and keep this in your notes. Keep it with probability maybe. I don't know how you're organizing your booklets. Ideally, you would want a binder where you put everything in. But so here we have a game, right? And they want you to calculate the expected value, right? And the name kind of says it, like, what are you expecting? Are you expecting gain or loss in the long run? So I'm going to do the work down here. Maybe I'll use loosely for that. Okay. So the expected value, you want to figure out the probability of winning as it says there. So I'm going to actually erase this. And in this case, the game consists of a deck of cards. If you draw a face card, you win 25 bucks. We all know by now that there are 12 face cards, right? So it's 12 out of 52. And we multiply that by $25 that you would win, but you paid $4 to play. So you really are gaining $21. In this case, that's the only way of winning. So as soon as you have that, you go minus, right? And then you have to figure out the probability of losing. And in that case, you would lose the $4 that you paid to play. And so if 12 out of 52 are winning cards in a deck of cards, then that would be 40 out of 52 ways of losing. Let me just turn off the front lights here so you can see better. So that's your setup. So I'm looking actually for this setup at first. I don't want just a final answer because often you'll get that wrong, right? So that then gives you, and I will go 12 divided by 52, which is 2308. 0.2308. That's how I prefer to do it. Times 21 minus 40 divided by 52. 0.7692 times 4. And then you go 0.2308 times 21. That gives you, here you can round because this is a dollar amount. 4.85 minus 0.7692 times 4. That's 3.08. And then it's just to subtract that, right? That's $1.77 positive. That's the number that you want at the end. Now, if you kept that as a fraction, all you need to do is 12 divided by 52, right? And then you multiply by 21. You still get 4.85 here. So regardless of how you did it. Let's be asking, should you play the game? So this is A, B, should you play the game? And the answer is yes. Expected value is positive. That's what you should be making reference to. That because the expected value is positive. If it's negative, then you should not be playing because you're expecting to lose in the long run. See, if you how much would you win or lose, right? You would win 5 times 177. So that's 8.85 over 5 games. It should probably be more like 500 games or 1,000 games or something, right? But kept it small there. So the number is like on average, that's how much you would win if you kept on playing a bunch of times. All right. That's it for this page. Backside now. This is going back to Trig and all of that stuff. So I'm just making sure you write this down. And this I can do right on this paper. Calculate the angle C. What kind of triangle is this again? Side, 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 right? Side, side, side. Does that ring a bell? If it's side, 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 we have to use cosine law. And it looks obtuse, right? So if you're trying to find angle C, oh boy, how's that formula again? Cosine of C. You write down this. You want to make sure that the side that's across that angle you're after goes at the end here, subtracting, and you square it. And then you take the other two sides, square them as well, but they will be added, right? So this squared plus this squared minus the side that's across the angle you're after. Okay? And then you go 2 times 1.75 times 1.15. This is actually, is this on your study sheet or formula sheet? I don't think this version is on there. Oh yeah, it is. Let me just show you here real quick. This is the formula I used just now. And notice if you want to find angle A, the side across from A is over here subtracting, right? And that's 2BC at the bottom. So if you don't have it on your study sheet, try your formula sheet. Now we're going to clean that up, right? We're going to figure out what the top is, 1.75 squared plus 1.15 squared minus 2.75 squared. Oop, and it's a negative. So we're going to have to be really careful with that. We know it's going to be an obtuse angle after all. So 2 times 1.75 times 1.15, that's 4.025 at the bottom here. And if you divide that, you remember how to do a negative? Some of your calculators have like a plus, minus, dash minus. That's the one you need to press to get that negative. So this is negative 0.7894. So angle C is going to be cosine inverse of negative 0.7894. I would encourage you to try typing in a negative with your calculator to see if that's what you're getting. Because if not, if you don't put that negative in, it's not going to be an obtuse angle. It's going to be an acute angle. Right? So that's how you do trig. Do I want to do that? Yeah, I will do number 3 quickly. For questions like these, we know that this is the same as that. So that's 10 centimeters. We want to figure out this length here. But before we do that, let's try to find this angle. What is this angle called again in a polygon? Yeah, it's the central angle. How do we find the central angle? 360 divided by the number of sides. So 1, 2, 3, 4, 5. And that is 72 degrees. So you basically found that central angle there. So now you have an SAS. You still also have to use cosine law with an SAS. So these two, SAS and SSS, are cosine law. If you don't have a pair, you can't use sine law. Remember that? It's been a long time. I feel like even I forget things like that. So if it's like that, then you need to, if you want to find this side, you need to square it and then take 10 squared plus 10 squared, right? These two sides minus 2 times the first side times the second side times cosine, right? Cosine of that angle. And then we square root whatever we get when we type that in. Make sure your calculator is set to degrees. And this is what you get inside the root there. And you write it out, you type this in, you get that. I take the square root of that, it's 11.7557. So the perimeter is there are 5 of these around it. So 5 times 11.7557. That's 58.78 centimeters. So a quick review. You have to use the central angle, you have to use SAS, SSS, you have to look at negative angles, right? Negative decimals, right? Which will in turn give you an obtuse. All of those things were in play here. So I hope that helped you to revise and review this. Look at that, it was 10 minutes.